Hello, William Rose. Today we're doing Lab 6, Module 6 experiments. This week we actually have 2 experiments we're conducting, and I'm going to go over my hypothesis, kind of my layout, my findings, and then also the preliminary kind of safety procedures and stuff like that. So I brought you to my kitchen today. Just made a little more sense to conduct the experiment. Safety concerns, we have one exit point there at the door. We have another one here by my cats. We are kind of in the middle of moving, so it's a little bit of a mess, but we have fire extinguishers still. And then obviously my sink and everything, so if we needed to dilute anything. So we had 2 experiments this week. We had the first one, which was enthalpy of ice cream, basically creating ice cream. And then the second one was the effect of temperature on rate of enzyme catalyzed reaction between hydrogen peroxide and yeast. So we'll start off with the ice cream. So we had the rock salt, sugar, vanilla extract, whole milk. I did not try the ice cream because I'm lactose intolerant, but looked good, smelled good. So starting off with the experiment, so it did call out for 4 tablespoons of coarse rock salt, and mine only came with 2 tablespoons of rock salt, so I did have a little bit of a deviation there. I also used ice cubes out of my refrigerator, which are a little bit smaller than a standard ice cube. And it's also, we have soft water. So they just seem to melt a little bit faster. So I replaced the 12 ice cubes with about 16 ice cubes, just due to the relative size. And everything else went kind of as expected. My hypothesis was that basically we would create a temperature, we would have the rock salt and water reaction. We would, through the water, we'd be able to get the salt water mixture to a lower temperature, and then basically the vanilla extract, the whole milk, the sugar would react once it hit a certain temperature range. So with that being said, my salty ice water mixture, initially I got down to -1 degree Celsius. And I did also use kind of the thermal insulation glove that it came with, and then I used a hot pad as well so that I wouldn't transfer the heat from my hands into the Ziploc bag. And I found that did help. I was able to get a little bit of condensation, which ended eventually around like the 4-minute mark. Ended up kind of having a phase change into like frost. So the gloves were definitely a helpful addition to get a more consistent temperature range and not have the variation. So like I said, -1 degree Celsius initially with the salty ice water mixture. My milk solution, I had my milk in my fridge, initially was at 8 degrees Celsius. And then I basically recorded everything with a thermometer in 2-minute increments, and I found at 2 minutes 4 degrees Celsius, nothing. 4 minutes, I was able to get down to 0 degrees Celsius, and then between 6 minutes and 12 minutes it was pretty consistent around -2 degrees Celsius. At 14 minutes I hit -2.5 degrees Celsius, and that's where I noticed kind of an initial phase change. It was almost like a slush type material, a little bit more aeration in the mixture. And then at the 16-minute mark, I hit -3 degrees Celsius in the milk solution. And that's where, it's supposed to say phase change. It says farm change. Don't know why. So look at that changed. But that's where I really noticed the phase change was at the 16-minute mark when I hit that initial -3 degrees Celsius. We're going to change that to phase. So pretty much matched up with the hypothesis. Shows that basically you'll have a reaction once everything hit the appropriate temperature range. So that one, pretty good. I wanted to try it with lactose free, but I didn't know if I'd have any deviations, and with moving and everything, honestly, a little bit of a time constraint. So I just stuck to the experiment. Okay. Experiment number 2. So that is where we had the effects of temperature on the rate of enzyme catalyzed reaction. So this one was kind of interesting to me because I thought the yeast and hydrogen peroxide would actually have a higher energy rate, well, from potential to its actual energy transfer between the chemical reaction. I thought that that was going to happen with the hot solution, the hot yeast hydrogen peroxide solution. In water, I want to say yeast enzymes kill off at around 140 degrees Fahrenheit, which I guess I'm in Celsius. So no, that makes sense. Yeah, I just didn't really think that through the calculation change there. So I thought initially that the a little bit warmer solution would have more of a reaction and the cold would have the least reaction. And through the experiment kind of found the opposite, but now that I'm kind of thinking and talking through it, it matches up. So at the cold temperature, had more of an energy release between the hydrogen peroxide and the yeast, and basically the vapor that was released from the chemical reaction caused the balloon to expand. I did let the balloons expand for a good few minutes, and I was able to get an increased diameter of the balloons. So initially, kind of hard to measure without any expansion. I got 10 centimeters. It was probably around 9, but it's hard to kind of get the balloon flat without stretching it or folding. But 10, I just put 10 as a consistency thing. And then here's my temperature that I recorded between the cold, the room temperature, and the hot. The cold, I just followed the instructions and I took my initial, initial would have been the room temp, and then the cold had the same time duration as the hot as far as exposure in my refrigerator. And so what I found was that the room temperature had a slight expansion, about 1 centimeter. The cold ended up having a 3 centimeter expansion, and the hot actually had no expansion, which now that I've kind of thought through, makes sense because the enzymes would have been killed off with a hot reaction, versus at the colder reaction, you have a little bit more energy release through the catalyzed reaction there. So that makes sense. What else? So I let it kind of expand for a few minutes until I noticed on the little vials, the balloon with the expansion of the cold was actually starting to kind of slide up on the vial. So that's kind of when I terminated it. I thought I had accurate enough results to where that was kind of a safe thing to follow up with. And yeah, good experimentation. I look forward to next week's as well. So hopefully I covered everything. Like I said, it ended up matching my hypothesis after kind of talking and working through everything. And yeah, thank you.